Good morning, learners, teachers, and parents, and everybody. My name is Trapezium, subject advisor of mathematics in grade 8 and 9, working at the Matao district. Today we'll be dealing with congruency and similarity. But as a way of start, let's remind ourselves that one, mathematics is a relationship subject. How's mathematical concepts built to another, fits another? How do you use the other one to deal with the other one or to solve the problems in maths? Two, it is that language. Mathematical language, we take it from our daily kind of home-spoken language, whatever language, to mathematics language that is understood by mathematicians. Now, as a start, let's look at the heart there, the heart. And just to look at why is language important. Yes, we should love maths. We should love this language and learn how to use this language. And this language, it's a problem solver in our daily life. This language is what we do on a daily basis. Now, the question says, can you find the area and the perimeter of the heart? So area normally is not that much of an issue, but perimeter, the word peri, and meter, we are measuring peri, around. You know, when you do your fence at home, surround, on the around, when you talk about periscope, the scope that gives you somewhere in the outskirts, periphery. So always remember, peri, we measure the outside. Perimeter, the outside, we measure it. Now, another important thing of a language and understanding, you can see you've got a half a circle here and half a circle here. So you want to calculate that circumference of a semicircle. You still remember the circumference of a circle is 2 pi r. Circumference of a circle is 2 pi r. So half of this 2 pi r is pi r, half of this 2 pi r is pi r. Therefore, already here we've got the whole circle at your circumference. And of course, plus this 10 plus this 10. So it's your 2 pi r, half a circle, half a circle, half a circumference, plus 10 plus 10. And again, area of the circle, pi r squared, half pi r squared, because half a circle, half pi r squared, you add them, is pi r squared, and of course the area of your square, 10 multiplied by 10. So I'm just trying to show you, if you understand the language, then everything is easy. So it's very crucial to focus on the language in mathematics. Right, let's continue with our lesson. We have done quadrilaterals already. Some earlier videos, get hold of them. Lots was done in terms of quadrilaterals, because congruency and similarity. We are going to use congruency and similarity, having this knowledge of properties. Right? In other words, it's important to remind ourselves about properties of quadrilaterals. Right? This quadrilateral, the diagonals of a parallelogram bisect each other. Because if, for example, you are given this diagonal is 20 and diagonal is 18, then you need to know they bisect each other. This will be 10, that will be 10. And note this side is equal to that side. This will be 9, this will be 9. And note this side is equal to that side. Just note there. Side equals to side. Right? Let's look at triangle AEB and triangle DEC. DE equals to ED. Right? AE equals to EC. Two sides already equal. This side equals to this side. Opposite angles, opposite sides of parallelogram. Sides facing each other, they are equal. Therefore, we've got three sides equal there. Three sides equal there. And of course, this angle, vertically opposite angle, is equal to this vertically opposite angle. So, in those two triangles, they are equal in both respect, in all respect. All sides are equal. This angle is equal to this one. We agree. Alternating angle equals to alternating angle. Alternating angle equals to alternating angle. So, those are triangles. In other words, they've got the same shape and equal everything. You must note that. We'll come back to that later on. This triangle and that triangle, they are the same shape, every measure. Right? Equal in all respect. Now, when you compare these two, you can see this one is a triangle, that one is a triangle. Right? But the angles will not be equal. We'll come back to that later. But here, what is most important here for you to remember is, remember a diagonal is a line from one side of this figure to the other. It's joining two corners, it's joining two angles. Remember that. This one is joining A and C. Remember that the terminology, the diagonal. So those properties are very important. They are going to help us to see, if you are given this side, you know what is the size of that side. If you are given that side, you know what is the size of this side. Right? And as well, the opposite angles of parallelogram, they are equal. Angle B is equal to angle D. Those properties are important. You'll see when we prove when you do some activities in congruency similarity. This angle is equal to this angle. Angles facing each other, opposite angles. Angles facing each other. That's what we mean by opposite. The opposite sides of parallelogram are parallel and equal. So also remember that this side, the opposite sides are parallel and equal. Opposite sides are parallel and equal. Then if you've got parallel, then alternating angles will come into the picture there. Co-interior angles, when you jam them, they give you 180. So it's very, very important for us to remind ourselves. Then your next one, let's see. The diagonals are still bisecting each other. These angles are also bisected. The diagonals also bisect the angles. The diagonals bisect each other. They cut each other into equal parts. These diagonals bisect those angles, they divide them into two equal, bisect. Same thing. Now that is a property of a rhombus now. And the opposite side of a rhombus, they are also equal. The opposite sides of a rhombus are parallel and all sides equal. Opposite sides parallel, but all sides are equal. So all those elements are very important for you to remember when we prove our congruency or similarity. When we prove our congruency and similarity. We'll come back to that one. Just quickly, you remember a rectangle, all angles each equals to 90 degrees. Again, the diagonals are still bisecting each other. But remember, the diagonals of a rectangle are equal. So if you are given a four-sided figure, they say the rectangles, the diagonals are equal, then you know it's a rectangle. When they say the diagonals bisect each other, it's either is a rhombus or parallelogram, depending of whether all sides are equal or only opposite sides are equal. So it's important to know all your properties. They will assist you to solve most of questions in geometry. Right? Here again, we've got another figure. Remember the rectangle there, all the angles each equals to 90. That's very important. Now we come to another rectangle, all angles equals to 90. But note here, the diagonals bisect each other. They also bisect the angles. So rhombus and a square, they bisect each other and bisect angles. But and all sides equal, here opposite side parallel but all sides equal. Opposite sides parallel but all sides equal between a rhombus and a square. But what is the difference? All angles of a square 90 degrees and not of the rhombus. What's the difference between a rectangle and a parallelogram? All angles here 90, they're not 90. But also note, opposite angles equal of a parallelogram, of a rhombus. Opposite angles equal. Note, opposite angles equal. And the diagonal. So it's very, very important to assist you going forward. Now we come into the trapezium. What do you have with the trapezium? One pair of sides parallel. Only one pair. And there is much to talk about diagonals. In trapezium, we don't talk about diagonals. We know if the lines are parallel, alternating angles are equal. Remember, it's a way of warming up. Right. The last one is your kite. What happens? The longer diagonal bisects the shorter diagonal. Opposite sides of a kite are adjacent, next to each other. Adjacent, remember I emphasized the point of the language. Adjacent sides equal. Adjacent sides equal. The diagonals meet at 90. Again, here we should also look at the rhombus, the diagonals meet at 90. Look at the square, diagonals meet at 90. Look at the kite, diagonals intersect or meet, intersect mathematically. Diagonals of a kite intersect at 90. Diagonals of a square intersect at 90. Diagonals of a rhombus intersect at 90. But remember, all of them bisect each other except of the kite. The kite one, the longer one, bisect the shorter one. Right? Like we said there, two pairs of adjacent sides equal, one pair sides of parallel. So it's important to understand the relationship of the angles. Remember, I said mathematics is a relationship subject. What is the situation in terms of diagonals? It's very crucial to remember that the four of them, parallelogram, rhombus, square, parallelogram, rhombus, rectangle, and square, the diagonals bisect each other. And then with a kite, only the longer diagonal bisects the shorter one. And in a trapezium, they don't bisect each other. Remember again, rhombus and a square, those diagonal bisects those angles at the corners there. So it's important to remind yourself, to assist yourself to know all these properties, because you'll see when we go to congruency and similarity why we need to know this thing. These are some of the questions in terms of congruency. We said congruency every side. Let's quickly look at the picture here. Let's quickly look at the picture here. Let's quickly look at this figure here. Let's quickly look at this figure. Our rectangle, let's put it that way. There's our rectangle. Quick. And rectangles, you know what you saw, like always, a rectangle is there in class. When you write test, a rectangle is there. The table you eat on is a rectangle is there. When you look at the ceiling, four-sided figure. Your 90 degrees. Opposite angles equal. Opposite angles equal. Right? And when we measure this side, equals to that side. When we measure that side, equals to that one. When we measure that side, equals to that one. And when we measure this side, equals to this one. So your diagonal, look at it. Here is a diagonal. Here is our diagonal. Here is a diagonal joining two corners. Joining two corners. Quickly. Right? These sides are parallel, remember? Therefore, meaning that this angle equals to that one. These sides are parallel as well. And remember, the co-interior angles give you 180 degrees. Right? And this angle equals to this one. Therefore, that angle alternating will be equal to that one. So when you talk about congruency, equal in all respect, the triangle, the green triangle, let's name it that way. The green triangle as opposed to the blue one. We are checking at the, how do they relate? They've got this in common. So they've got the common side then. Equal. They've got opposite sides equal. They also got those opposite sides equal. They've also have 90 degrees equal. They also have alternating angles equal. So they are equal in all respect. In all respect. Let's cut it this way and see. One, they are the same shape, same size. Same shape, same size, which is a shape of a triangle. Which is a shape of a triangle. Let's see. Exactly the same. So the first triangle is exactly the same. Same shape, same size. Same shape, same size. That's congruency. That's very important. Right. That is congruency. We can also take, let's take two other pages. Your rectangle there. And another rectangle on top of it. Same shape, same size. Rectangle equal in all respect. That's what we mean by congruency. That's what we mean by congruency. So every time there's a question about congruency, you have to prove to us what is equal in both of those figures. Okay, let's continue here. Right, in other words, you'll be looking, like I said, properties. You'll be looking at the sides. In that case, are the three sides equal? Number one. Number two, angle and a side in between and an angle are equal. Of the two, you compare the two. If three sides are equal, then they are congruent. Same shape, same size. If an angle and a side between the angles are equal of these two figures, then they are congruent. If a side, angle and side are equal, then they are congruent. If the hypotenuse, which is your L, the side opposite 90 degrees, and any side are equal, then congruence. If you've got angle and a side equal, then those are the kind of things that we'll be looking into. Now, taking a break, look at those sides, whether you can find sides are equal, angles are equal. Can you write the relationship? I'll give you a few minutes to work on that, and then I'll come back, we discuss that.